Bismillahirrahmanirrahim. Previously we talked about the segment addition postulate, and it said if 3 points, if A, B, and C are collinear, like this, if they are collinear, then point B is between AC if and only if AB plus BC, the two baby segments, AB plus BC, if you add them together, and if they add up to the big segment, AC. So this statement says, again, if A, B, and C are collinear, then point B is between A and C if and only if AB plus BC equals AC. In other words, if two baby segments equals to the big segment, then they are all collinear. This also allows us to do the other way around. We can say that two baby segments give the big segment if we already know that the 3 points are collinear. And that's very important. Again, let me repeat myself again. We said that if we know that two baby segments give you a big segment, then these 3 points must be collinear, and that's the only way that can be. So this is the segment addition postulate, and prior to that we had learned some properties. These were the properties of equality for real numbers. And then I had given this proof. This proof was like this, okay? We were given this diagram, and we were told, let me get my pen ready here, we were told that CE, this little segment here, was congruent to this little segment there, and then we were told that ED was congruent to EG, that is, ED was congruent to EG like this. From there, we were asked to prove something. We were asked to prove, in fact, that this segment over here was congruent to this segment over there, like this. Now, that, as I said before, that may seem readily apparent to you. And as I said before, that may be reasonably readily apparent to you. As if you take the two baby segments were given, and then the two big segments are congruent, and the whole segments added together must be congruent. And we had set up this two-column proofs over here like this. First, we wrote down the given information that CE was congruent to FE like this, and ED was congruent to GE, that's this was congruent to this. And then first we converted the congruence into equalities because we know some properties of equality for real numbers, and so we changed the congruence to equalities. So we changed the congruent statement to equalities over here, and then we used the segment addition property to state that CE plus ED was equal to the big segment. And then we substituted FE and EG, and then we got this FE plus EG equals FG, and then we used the segment addition property again, and came to our final conclusion. Now, you might say to yourself, wow, well, this was pretty obvious to me, but it seemed like we made things more complicated than they needed to be. So why do we make things complicated than they have to be? No, that's not really actually the case. And it may seem that way in the beginning because the material seems kind of challenging because of unfamiliarity. But this is actually quite elegant proof, and I hope you appreciate what we did over here, and that's the objective of today. What I'd like to share with you today is to go over this proof again, but in a more visual sense, to give you an idea of what a remarkable thing this little proof is, although it may seem kind of a little exotic in a way. So here's the problem again. And I just rewrote it, and then and a thought came to me: it would be nice to try to demonstrate the same problem using Lego pieces. So here's Lego piece over here. I've kind of pictured them, and then there's a blue pieces, and there are the yellow pieces. So what we are given here is the following information. All right. Now we're given the two small pieces over here. This blue piece over here is congruent to this yellow piece over here, like this. Okay. Now it can't be yellow here because then we're kind of overlapping each other, right? But you get the idea. We were told that the two small pieces here are congruent, correct? That's very good. So the two small pieces are congruent. This one is congruent to this one, and we're told that the two medium-sized pieces, the blue one here, this one, and this one are congruent, correct? So we are told that the two small pieces are congruent. Come on now. And then the two medium pieces are congruent. And from there, we are asked to derive the following conclusion. Here we go. Behave yourself. Okay, here we go. There we go. Now, from this, we are asked to derive the following thing. The proof is to prove that the two big Lego pieces over here are equal. Now, when you visualize it like this, and it's obviously pretty obvious, right? But look what we are asked to prove. We're given two small pieces are congruent to the two medium-sized pieces are congruent, and from here the two big pieces are congruent. How are we going to do that? The only thing that we know is, that we learned so far are the segment addition properties. Now observe the segment addition property over here. If you look carefully, the segment addition property is talking about one segment. In this case, I have the blue segment. The two baby blue pieces, small and the medium size, if you add them together, you get one big piece. Now that's quite remarkable if you think about it for a second. The segment addition property is talking about one segment. It's not comparing segments, it's not comparing blue and yellow pieces. But we're going to use the segment addition property to prove the some aspects between two separate segments. That's very important to appreciate. So the segment addition property says if you have two baby segments and you can add them together to give one big segment if all 3 points are collinear, right? And then we are using that to prove two separate segments because we also know that some properties of real numbers. So using the properties of real numbers, which we had learned before, and using this one small postulate, the segment addition property, we're going to prove something different altogether. So here we had set up our two-column proof like this. So when in doubt, as I said, you start with the given information. So the given information was that the small pieces are congruent and the two medium-sized pieces are congruent as well. Now I've written equal sign over here because it's kind of cumbersome always to go from if two segments are congruent, that means they're equal length, right? In fact, we will have a property of congruent segments shortly to expedite that for us. In other words, it's very difficult. It becomes kind of cumbersome after a while to say if two segments are congruent, that means they are equal. So this because you do this all the time. So we come up with properties of congruent segments, which says if two congruent segments are congruent, then they are equal measures. So this becomes a little easier in the future because we don't always have to keep saying this. All right. So anyways, when in doubt, as I said, you start with the given information. Behave now. Here we go. All right. Now, so two baby segments are congruent. That's the given information. Now, where can we go with this, right? So where can we go? Now you have to think about this. We don't have a lot of at our disposal for us here, and we just know properties of segment addition postulate, and we know the properties of real numbers. Watch this. There we go. So you see, when you're doing a proof like this, okay, you have to think. You have to have a bank of information. You have to have some properties. You have to have some postulates, axioms, and theorems that you rely on. So that's one of the points of this, is that you really have to know every theorem, every postulate, and every property, because those are the facts. Those are the information. Those are the properties you're going to rely on to create bigger proofs. So far we only know the properties of real numbers, and we know this segment addition postulate. So okay, well, it looks like you're adding stuff, right? So you might as well start by stating segment addition postulate. According to the segment addition postulate, this is what we know. According to the segment addition postulate, we know that you take these two baby segments and you can add up to a big segment like this. But then look at this segment addition postulate here. It only has all blue pieces, right? It doesn't have any yellow piece. But that's not what we're trying to prove. We're trying to prove that this big blue piece is congruent to this yellow piece over here, right? So at least we have a start here, because here we have one blue piece over here, right? We have a blue piece going for us. So we got that in there. So that's pretty cool. So what do we do now? Well, what do you think? Well, here's the idea, see? So let me get my eraser again. Look, I'm learning how to use the eraser over here. And then I'm also learning how to change this eraser. It's kind of embarrassing to do it while I try to read. Okay, anyway, here we go. So the idea comes like, well, you know what I'm going to do? I need some yellow pieces in here somehow. Well, I know the blue piece, small blue piece equals the big blue piece. Small blue piece equals to the small yellow piece, so I can just substitute that in here. And I know the medium-sized yellow piece equals to medium-sized blue piece, so I can like substitute that over here like this, can't I? Absolutely, I can. So that's what I'm going to do. I'm going to substitute this yellow piece in place of this small blue piece. I'm going to substitute this yellow medium piece in place of the small blue piece. And when I do that, I get this. And I can do this because of substitution property. Because the substitution property says that if A is equal to B, then you can substitute B anywhere A goes. Okay, so if these two are equal, and I can just take the blue piece out, put the yellow piece in. If these two are equal, I can take the blue piece out and put the yellow piece in. Now I got this. Now that looks much better, right? Because now I got yellow pieces and blue pieces, okay, in my equation here. Now what can I do? Well, all I have to do is add them together, and then I get a big piece of it. But you can't do that. You have to tell us why is it that you can actually do that, and that's a legitimate move to make. Okay, fine. We can do that because we already know that 2 baby pieces equals 1 big piece. So the same applies to the yellow piece. What applies to the blue pieces applies to the yellow piece. So the blue, 2 baby Lego segments equals 1 big segment. This is, again, because of the segment addition postulate. Now we know that these 2 yellow pieces equal to this big piece. So I can take big piece here and substitute over there in place of the 2 small pieces over here, right? So, and then that's what I do. And fifth, then because of the substitution property allows me to do that again. So now we know that this can be substituted over there. Now I have a big yellow piece is equal to big blue piece, and we're done. Because that's what we're trying to prove. We're trying to prove that the big blue piece is equal to big yellow piece. Now technically you would say, well, we were trying to prove that the blue piece equals the yellow piece, not the yellow piece equals the blue piece. That's okay because of not reflexive property, but because of symmetric property. If you really wanted to be like super nerdy, you would flip these around, and because of symmetric property of equality, and then you'd be really done. But this is sufficient for us for now because all Lego pieces won't fit out in the whole screen. Now observe again the beauty of this particular process. We used what we know from the properties of equality for real numbers, and what we know from a single postulate, which is segment addition postulate, to prove something as elegant like this. And mind you, the segment addition postulate was talking about one segment, and we used that one postulate to prove the 2 separate segments were in fact congruent to each other. And that's the beauty of this. It's of this entire process in my mind, and I hope you appreciate that. And I encourage you to know these postulates and theorems and axioms and properties really thoroughly, because as if you have them right in the forefront of your mind, like it's like in your palette in artist painting, then you can access them very easily to create these proofs. And I hope you appreciate this and enjoyed. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.